So hi everyone, welcome back to Data Science in your pocket, and today we are talking about GSPO, Group Sequence Policy Optimization, a reinforcement learning algorithm to train Qwen3. So recently you might have heard of Qwen3 has beaten all the models and is one of the best open source model now. So what was their secret trait? That is GSPO. So if you remember, when DeepSeek came into the picture in January, it break the internet, and the algorithm used for reinforcement learning was GRPO. This is an upgrade over GRPO. So I will be telling you a little detail about GSPO. We won't be going much into the technical details and equations, but this is a shallow introduction to GSPO. So first of all, talking about reinforcement learning in large language models, training LLMs with reinforcement learning for reasoning capabilities, following complex instructions, and alignment with human preferences. So if it is aligning with human preference, you give it a reward, else you give it a penalty. Now when you apply reinforcement learning to huge models like very large models or mixture of experts model, it is very difficult, right? One more issue with basic reinforcement learning is the reward is for the whole output, right? But updates happen at token level. How I will tell you. So first of all, you need to understand what is PPO, right? This is also the base algorithm. It is a cautious optimizer that keeps the new model proximal to the old model. So what does it mean? So for example, if your model is A at first and after upgrade it goes to B, this won't be a huge jump. It won't give you a spike. It will clip out the update to a certain extent. Hence, you won't be going too far away from the previous version, right? It helps you from exploding things. So, but PPU has multiple limitations. It struggles with long text. Model gets confused about which tokens were responsible for the reward, right? Because you get the reward in reinforcement learning at the last, but the token is getting generated after a sequence, right? So it doesn't know for whom the reward is given, and a single word can flip the meaning. But token level grading misses this context. So to improve on that, I think GRPO algorithm was introduced by DeepSeek, right, which eliminates the value model which is used by PPO. But still the issues remain the same. I think it was still calculating at token level only. And again, it going with the general sense, when the reward is for the whole sequence, why would be upgrading token by token? So this is the new thing that GSPO has introduced. That is, instead of updating tokens, it updates entire sequences. So sequence level optimizations happen, sequence level clipping happens, and equal total token treatment. All tokens in the sequence gets the same treatment, right? So how GSPO works? Let me give you a small example. This is a very dummy example. So to understand GSPO, you need to understand GRPO also, that I have already covered in my previous video. You can have a check there. It's a little difficult algorithm. I'm just trying to make it a little shallow. So group sequence policy optimization basically means that you are taking group of updates, right? Number of outputs, and then depending upon that, you are updating your model. So assume that the prompt was write a poem about ocean, and completion one was the waves crash gently on the shore. Completion two was this, and completion three was this. Three outputs were considered. Now, first of all, you would be calculating the mean and standard deviation, and then you would be calculating something called as normalized advantage for the entire sentence, right? These are the rewards: 0.8, 0.4, 0.6, the numbers that you're seeing that you got from the model. And then the entire update is applied to the full sequence. There is a concept called as importance ratio that gets calculated, but for the entire sequence, and then applied to the entire sequence. You are not calculating anything separately for tokens. This is what GSPO is changing. I'm not jumping into the equations, else it will become very difficult for you to understand. But just try to understand the crux that in case of GRPO, you are updating the tokens one by one, while in case of GSPO, you are updating the entire sequence. GRPO versus GSPO, key differences. In GRPO, token level updates happen, while in case of GSPO, it's sequence level updates. Clips each token independently in GRPO, but in GSPO, the entire combined update is at sequence level. The clipping happens at sequence level. In case of GRPO, high risk of collapses, especially in case of long outputs. While in case of GSPO, this risk is lower. GRPO is slower training because you're updating every token, right? While in case of GSPO, it's a fast training mechanism. Why GSPO matters? Multiple reasons. It brings in stability, it is more efficient, better aligns, and it is best suited for mixture of experts. So if you know, Qwen3 models that have been released are mixture of experts model. Should you use GSPO? I think yes. These are the conditions when you should consider GSPO. When human feedback is required in training. Preference model, when using reward a preference model for alignment. When you're using MOE architecture, then you should definitely use GSPO and unstable training. Here you can see that key benefits are it's cleaner, aligns optimization, it is more stable and more efficient. So with this, it's a wrap. This is just to give you a hang around what is GSPO. To understand GSPO completely in terms of mathematics, you need to go deep dive into GRPO first, that I've already covered in my previous video. And to understand GRPO, you need to understand PPO. So I'm not going into that technical depth. I'm just trying to explain you how GSPO has come into the picture by Qwen3. And soon I should take up an attempt to explain the mathematics also. Thank you so much. I hope you have a good day.